Welcome, folks. So talking to a lot of people over the last day or two, AI is one of those topics that's just, it's on everyone's lips. And I suppose it started with, when we looked at ChatGPT, probably, around November 2022. I know everyone from parents to aunts to uncles now know about AI. And as a consequence, it's becoming more and more prevalent for us, as developers, contributors, whatever area we work in. So for me today, I want to look more from the angle of the developer that's going to consume it. So, there's lots of conversations around the models and the trust, etc., and how the models have been generated, and I leave that to one side. I'm more concerned in how are we going to use the models on our applications to make our applications better. Do we need the models? When should we use the models? So it's more around here, how to use the models is what I'd like to talk about today. So my name's Martin Hickey. I work over at IBM. I'm an open source developer, and I've been working probably in cloud native space for the last 8 to 10 years. Started downstream and then up into upstream. And for the last year or so, I've been also looking at AI. And again, from the angle of, first of all, how do you consume and how do we use it? But also then trying to understand some of the models as well, which, I take my hat off to data scientists and ML engineers that are developing these models. So just a quick look at what we're going to discuss today. As I say, I'll do a small little background around AI. Don't shoot me down if you think I haven't covered enough in it. I just want to give enough to touch on it and around the models and so forth. The frameworks really I want to talk about and see how they are. We'll hopefully get a quick demo in. We'll see how Nick is over there, if he gives me a little bit of time. And then we'll just wrap it up. So when I was looking to, when I first was starting playing with models, the thing that stood out to me was, what really is a model? So I've put two definitions up here that I pulled off the IBM site. And to me, when I look at it, a model is a program that needs to be run, that you can use. It's been trained on data using an algorithm. And it's trying to achieve a task or an output that's relevant to that input you're putting in. So as our North American friends would always say, garbage in, garbage out. And that seems to apply with models. And I'm concerned about how to use that model. And coming from a traditional programming background, and most of us probably that are developers here come from that area, especially if you're a certain age and you're kind of bald and you've got glasses or you're older and so forth. But we always, as programmers, you write the rules explicitly. Your instructions are there for the computers to use, and you can look at that. Whereas now we're looking at totally different things with models, because models, they learn patterns. They learn relationships from the particular data, and it enables them to make these predictions and decisions afterwards without being explicitly programmed to do it. So it's a totally different concept when we look at it, okay? And it's getting your head around that and how to use it. So I look at it from the angle of it's a program I can use, like an API to a service before, or a third-party library that you want to use to do something for you. So, maybe, every day you're not going to go out and write a binary tree algorithm. You'll just use some library to do it. The same concept here, to get the models to do stuff that we can build our value on top. Just a little around the journey of where a model comes from and how it starts out. So the first part of it is around the building of that model or the prototyping of that model. And we go back here to the data again. The data is really, really important, and where this data comes from. And that's the first part of your data loading, is getting it from that domain knowledge from SMEs that you can trust. So for example, if your model is going to do something with sport information, to get it from reliable sports sources, with language as well. Where do you get your different languages from? And I'm talking about human languages like French or English or whatever. The next thing is around prepping the data. Because when you get that raw data, it isn't exactly optimized or in the right format for the algorithms to be able to create the model from it. So there's things looking for errors or any omissions, any missing values, you know, as I say, converting into a particular format because it mightn't be reconciled in the time and space that you're going to use it in, and then aggregation, etc. So this is actually where I was blown away when looking into the models, and I'm going to keep learning on this, is, you know, trying to get my head around it, you know. Because I think anyone that puts their hand up there and says they understand models inside out, you know, are either a genius or they're just bluffing. Because if you go in looking at those models, it's not easy to figure out sometimes, you know, when you change the data as well. And that's where I think, and I'll talk about earlier, is having it open, having trust, etc. on the models is really going to come into it, because it's hard to understand exactly sometimes how those predictions come about. But maybe a data scientist will come up to me afterwards and tell me I'm wrong, but there we go. The next part then is your algorithm, and your algorithm is going to depend on what you want the model to do. So that's going to depend on, as I said, the problem you're trying to solve, the resources you've available, and the nature of the data. So, you know, obviously the problem you're trying to solve is easy. The resource you have is, well, you know, how can you train that model? Do you have enough CPUs, GPUs, you know, have you enough, I suppose what we'd call, when we talked about machinery before, enough horsepower to be able to train that model? Because some of these models take a lot to train, they take a lot of time, so resources are very important. And then, of course, the type of data you're putting into it. And there's a number of algorithms out there. They're based on supervised learning. That's, I suppose, previously the machine learning or ML models that have been there previously were based around specific data that you labeled it, and they were for specific tasks. Now we're looking at more unsupervised learning, where basically it's for more generic, putting no labels around it and training it into specifics, for example, like the large language models we have today, and then reinforced learning, which is a new concept of checking that learning afterwards against models or against humans. The training then is the part that where you're going to train the algorithm against the data to see that your output is within a tolerance that's acceptable of error. So you're not, in a lot of these cases, it's not going to be 100% correct, but is that error level enough that it's acceptable? So training it against large sets of data, depending on the type of models you're doing, and then you've got your model. So the last part of it then is the validation of that model. And so this is where you see, right, I've trained my model, I've saved my model against a set of data, I'm now going to get some new data that it hasn't been trained against to see if the output is feasible or acceptable for you to be used in production or to be used by folks. The next two parts are the parts I'm interested in, really, if I'm honest, which is the hosting, which is called hosting or serving. So this is, as I've said earlier, like a model, you think of it as a program, it needs to run somewhere. So, you know, if you're doing something on your own laptop, obviously you load it up into the memory space that you're on, depending if it's Python or whatever, you'll run it with Python or whatever the language. But generally what we're looking at these models, they're going to be deployed out into cloud systems or out into bare metal or however you want to deploy it. And then it's calling that model afterwards, which is called inferencing. So when you inference a model, you're then calling the model, you're giving it some data and you're asking for a result back or a task to be performed. So the last thing I just want to touch on is generative AI, because this has been really the buzzword for the last 2 years, you know. And the key here is around the models, or the type of models. And they're based around the idea of the foundation model. And as I mentioned previously, this is a change that was there from the ML models before that were trained with labeled data, and they were usually for specific tasks, required a lot of deep knowledge from data scientists and ML engineers for the particular domain. So the change here was, right, let's take models that are going to be trained in a large set of data, but unlabeled data mostly, maybe supervised data as well. But the idea here that the model can be used for more than one task or one domain. And then if you want to fine-tune that model then to a specific domain where you can take that model and train maybe some of the layers. So these models are usually deep learning models, which means they have many layers, 3+ layers in the neural network. And what you're doing in this situation then is you might take some of the top layers off and train it with your data or your specific data and then save it. So that's fine tuning. Or you might use prompt tuning, where you just take the model as is and you give it prompts going into the model when you're asking it to do an operation. So for example, you might give it examples of what you're looking for, or you're going to give it specific clear instructions so that you see if the model can give you the result that you're looking for. And this is where your large language models come from. They're a subset of foundation models. And as the name suggests, they're based around language and their understanding of language and the generation. And this is where your generation AI comes from, is the idea here that you're using models to generate something, either text, video, audio, whatever you're looking for. So you've great examples now, like a geospatial model that IBM did in collaboration with NASA, and they've now made that model open sourced under Hugging Face. So this idea here that the models that was used for a specific thing, the geospatial is very important now, because it was used initially, I suppose, for analysis of planets and so forth, but now it's for our own planet, and it's been used for a lot of causes around, predictions of weather conditions and stuff in different parts of the world. Right. So let's change gears into the frameworks, which is the part that I'm interested in. So first framework I'm going to mention here is around Hugging Face. Hands up here who's heard of Hugging Face. Okay, we have a good audience. I should have probably asked this earlier. Hands up here, anyone that's a data scientist. There's one. Okay. ML engineer, 2 maybe. Hands up here who are mostly development. Okay, I might be safe enough to get out of here. Okay. All right. No slagging at the data scientists, I hope. So Hugging Face, for the people that don't know, that might have heard of them, are a company that's based around that have created an AI community, and it's based around open source of the libraries, of models, and their data sets. Okay, so they have a huge catalog of models that you can bring down, and these are all models that have been open sourced by different companies, like your Googles, your IBMs, or whoever. And then also they have a series of libraries, handy libraries. One of them is the transformer library, which is quite handy for generative AI models. You can just, I'll show it in a couple of minutes. You can just use pipeline, and you get handed to the model, and then you can call the model. It's very handy, and it downloads the model for you. I'll show it in a second. They also provide a service around the hosted, where you can call their models directly that they've hosted on their particular servers. For a lot of companies, and talking to customers, they like the ability of that you can pull down the models and have the models and run them locally for GDPR, for data security, and also just in case maybe, I don't know, the company disappears in the morning or something like that. And what I'd like to do is just kind of show a simple example as we go through it. I've pulled this example from Ray, of all places. But here it's just using that transformer library I was talking about from Hugging Face. And using pipeline, you can specify the particular model and the task you want to do. In this situation, I'm using a T5 model, which is an open source model that's very handy for NLP tasks, or natural language processing tasks, so that it understands, an input sequence going in, and it can generate output in this. In this situation, it'll take the English in, it'll generate the French out. And it's a very, very simple program here, and you can call it with Python. So when you call the program here, the first time it's called, it's going to pull down that particular model from Hugging Face, and then after that, then it'll cache the model, and it's just used from cache. Obviously, here I'm just running it on my local system. Ray. So Ray is an AI framework for scaling and distributing Python and ML applications. The capabilities it provides is around batch inference on CPUs and GPUs, model serving, loading the models and running them, training of large models, and reinforced learning. So capabilities like that. So with the Ray framework, you're looking more on deployments and stuff like that, and loading the models, having the models available. And it also provides a toolkit to serve everything from your deep learning models that we talk about now to frameworks like PyTorch and TensorFlow, etc. And if we want to use it, sorry, when I wrapped it in the template, it got a bit busy, the slide. But what I want to show here is that if you want to use Ray to host it, then what you need to do is, first of all, wrap your class in an annotation, a Python annotation, serve.deployment, and then you can pass different params in if you want through there. And then the other part then is you need a call method, an underscore call method, that when you call serve using the Ray HTTP server, when you do a serve run on it, then it's going to export the particular class view. It's going to provide the interface on it, and you can call it through a HTTP request, as I shown below. And the last framework that I want to look at is the Triton inference server. And the inference server provides support for most ML languages, frameworks such as custom C++ and your Python backends. And you can see here the different frameworks it supports, and also its processor support, etc. For this particular framework, you actually need your class has to have a particular name, and in all these instances, I'm using Python as the example here. Your class needs to be called Triton Python Model, and it needs an execute function, and the execute function will then be called when the particular model is served. Now, in this situation, and it differs to, I suppose, Hugging Face and to Ray, is it doesn't deal with your JSON or your Python types. It deals with tensors. So if you've used PyTorch or any framework like that, it's tensors in, tensors out. So you can see here, there's a bit of data manipulation from the tensors into the particular Python types. And again, all it's doing is calling the particular Hugging Face transformer library to use that model. You also need to bootstrap this using a config file. And your config file here on the right-hand side is, you need to give it the name of your particular model you want to call. And I suppose it's really the wrapper model, not the actual model that you're calling. And then your backend in this situation is Python. And then there's your input outputs, and there are your tensor types, the text and translation text out. And you also need to have a directory structure like this. So, you know, in this situation, the root directory will be models, and then your particular models underneath it by their name. Translate here, and you have the model class and the configuration. So you can see with these different, and finally then to show how to use it, there's different ways with Triton Inference Server. One of them is using their server container. So you kick off a container using, in this case, Docker run to do it. You then need to use that model directory that I showed previously into the container, and then you can start the Triton HTTP server using, in this situation, Triton server is called, and it points to the particular model directory. And any models that are in there, they'll be loaded up by the server. And finally, then you can do your inferencing using the HTTP request there. So I've just chosen three AI frameworks in this situation. What's really interesting around this space is how much it's grown, especially in open source, the amount of frameworks. They're like mushrooms really at this stage. You know, there's a lot of frameworks out there, and I've just touched on a few here. So I suggest you go out there, have a look, see the different frameworks, try them out, and see what suits. And I think really the way that we're going to go forward will be with open source in this area, where we have the ability to use these different frameworks, where we'll have a certain amount of the models will be open sourced, and it'll give us transparency and and usability of these models. And then other models then that may be the proprietary models, all of them will require an amount of trust. And who do we trust to provide us with these models? And the inputs and outputs, will the outputs be as we expect? So what I'm going to do is just change gears for a second and do a little demo, okay? Let's see how the demo goes. So first up, actually, I just want to show you. So what I'm using here is, I'm just using a framework called Hickey. And this is, the demo I'm showing is a colleague of mine did it called Max Stuvert in the States. And the framework here is pretty similar to the other frameworks, like Array and Triton, inference server. And what it does is it just wraps the model. You tell it what its callback is, or it calls into, and then it loads the backend server, and then also loads the UI. Okay? So that's what's just happening here. And if I look at a simple example, I'm just using a simple example around different types of models. He's used Gradio here for the different tabs, which is a UI framework, Python UI framework. And in each tab then, there's different type of models we call. But I just want to show the idea here of that it is just calling the models to do capabilities, to use it inside your application. So the first one is around sentence similarity. So if I say the canine is fast, and then if I go, the dog is running, and the cat is. So we'd be assuming sentence 1 is probably the nearest to the source sentence, we hope. And you can see here, yeah, it's saying 68% the dog is running because the dog is a canine, you know, and it's running, so it's fast. If we change around the cat, and we say the cat is running, probably what will happen now is the sentiment its percentage should increase. And you can see now it goes up to 36%, because in the vector space of the words, cats and dogs are going to be near each other. Fast and running are words that are quite similar. And canine really is a dog, so that gets a higher percentage. So that probably makes sense. If I look at an image classification, I'm going to choose an image here. I'm going to choose this dog. Hopefully it's not your dog I got online. Okay, so I want to know what type of dog this is, which is a nice puppy. And it's saying 88% golden retriever. I'm not sure my golden retrievers from my Labrador retrievers. Does that look like a golden retriever? Yeah? Okay, all right, thank you for that. Okay, so that seems to work okay. So the final thing is I'm going to do object detection. So we have a sport in Ireland called hurling. Hands up, has anyone ever heard of hurling, the sport? One kind of half hand up the back there. We've no hand. Oh yeah, don't be shy. Right, so I'm after just picking a picture here off the web. And yes, 100% of sports ball, it's identified persons, but it's identified the stick as a baseball bat. Now, the stick is called a hurley, so obviously it's done a bit of hallucination here and just picked whatever it wanted to pick. But it just shows you as well, because these are large language models, or foundation models, they're going to be trained on a certain data set. So if you wanted that to be more accurate, then you'd probably have to put a data set in of around the intricacies of the game of hurling, and then you'd get to it. So from a code point of view, why did I show you that? Because I just want to show it's just code. So the first part here is just the Gradio app where the different tabs are added. And you can see here it calls the optional function the whole time. And then here's a series of the wrappers for the different tabs for the UI. And you can see here in the optional tab here for one of them, image classification, the last thing we looked at. You can see here it's dealing with the different elements that's on the tab. And one of them is the submit, is it's going to call a function called fun, which is a great name, obviously. I haven't used FN for a long time, but obviously Mark likes that. So you can see here then, it calls a method called self-predict. And this is a gRPC call because the particular server that's hosting the model provides a gRPC interface and a HTTP interface. He's after using the gRPC interface. And where does that call then? Well, what it does in the UI is going to create its channel out to the particular server that we have running. and then it's going to call into the models that have been wrapped here. So like the models that were wrapped for Ray and the inference server Triton, these models need to be wrapped as well. They use an annotation model in this situation, give it an image classification, a task, etc. You can see here again, in the init, simply just call in pipeline for the particular model if the model is passed. If not, it's going to use the default Google VIT-based patch model. And then you can see here then in the run method, which is a callback or the inference when you call it, it's going to call self.pipe with the image. The results are going to come out and they're going to be sent back to the UI. And that's what I showed in the UI there. So getting back to the deck to finish up. Okay. So what I've done here is I've done a very, fast run through of models. And I call this really, a lot of people just hop into their vehicles, turn on the engine and take off, okay? And whatever the engine's done underneath, they don't really mind. Now I know there's probably a few petrol heads out there that you love your engines, you love playing around with them, that's great. But for a lot of people, it's able to use this. And I think this is where models will come into their own. What is the use of model? How is it going to make it easier for me to write my application? What capabilities can I do? Yes, there's going to be trust, security. All those things are incredibly important. But if you've been told, it's the same as when we've used third-party libraries or open source libraries to do stuff. We want to be able to bring technology forward, and we build on top of things that help us do that, rather than writing everything from scratch. And that's going to be the key here. Keeping it open, keeping open source driving this forward is going to be the key to this. But if you're there and you have been told probably, because more and more companies are driving forward with open source, with AI, and it's gone from, I suppose, the spam detection, generation of emails, chatbots type approach, to bigger and better things like we've seen with geospatial and so forth. So the key here is, how do you use it? That these models can be run like any program. There's going to be an interface in them, and you can call them. So thank you.